Good day everyone! Welcome to That Friendly Writer's Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about how to compare a sample mean from a population mean using a t-distribution. In this video, we shall organize the ideas in a statistical table in preparation for a quantitative research. Alright, let's get started. In this example, suppose a population mean mu is 50. However, the sample showed a mean of 56. This shows that we are expecting a mean of 50. Well, we know it's not going to be exactly 50, but more or less around this number. But we got a sample mean of 56. Can we consider the sample to be significantly different from the population in terms of their means? First, we identify the groups. In this case, we are comparing the sample from the population. We write the values that we want to compare. In this case, we are comparing the population mean mu of 50 and the sample mean x bar of 56. Next, we calculate the t-stat of our x bar using the formula t equals the square root of n times the difference of the two means all over the sample standard deviation SD. We plug the necessary values. Sample size is 9, x bar is 56, mu is 50, sample SD is 6. The square root of 9 is 3, because 3 times 3 equals 9. Also, 56 minus 50 equals 6. Multiplying, 3 times 6 equals 18. We divide this by 6, and the result is 3. Our x bar then has a t-stat of 3. Next, let us draw the model t-distribution. Unless mentioned in the problem, we can always stick to a two-tailed 95% confidence level, which means that significance level alpha is 5% or 0.05. How many degrees of freedom do we use? Remember, sample size is n equals 9, so our degrees of freedom df is 8. And our model t-distribution, whose critical value is 2.306 when we use the t-table. Actually, what we just need is a critical value, in this case, 2.306. We write this in our table under t-crit. At the moment, we shall immediately skip to significance. Because our t-stat of 3 exceed the t-critical of 2.306, we shall be considering this difference as significantly far from the mean mu. Remember, when the t-stat is greater than the critical value, then we can consider the difference as significant. What does this mean? We were expecting mean values to be around 50, more or less, but we got a value of 56. This is significantly far from what we would usually expect. Hence, a significant difference exists between the population and sample in terms of means. Here is the final clean appearance of the statistical table. How about a second example? Dogs show a healthy heart rate of 90 beats per minute or BPM. Louisa's dog only showed 80 BPM on average over 16 trials. Let's use a 1% significance to determine whether Louisa's dog showed a significantly different heart rate than what is expected. First, let us clarify that we expect 90 BPM, not really exact, but at least more or less. But we got an 80. We are comparing a population with a sample in terms of their means. The population mean mu is 90, while the sample mean is 80. The sample mean of 80 converts to a t-stat of negative 1.6. We use a two-tailed t-distribution with significance alpha of 0.01 because it says so in the problem. Because the sample size is 16, the degrees of freedom is 15. Hence, the critical value is negative 2.947. We do not mind the positive critical value because our x bar is less than mu. We identify where the t-stat of negative 1.6 is, and it's just a little to the left of 0. Comparing the t-stat and the t-crit, we can see that it's not yet inside the critical region, so the difference is not significant. Remember, if the t-stat is not larger than the t-crit in absolute values, it is not yet considered significant. This means that Dogs display heart rates of 90 bpm on average. Luisa's dog showed 80 bpm on average, but this is not significantly far from the average. This is still within the usual range. This is not yet significant. This means Luisa should not panic as a fur parent, although a trip to the vet would be helpful as well. And this is the formal appearance of the statistical table that compares the sample mean and the population mean. We skip the other two columns for a future discussion. And there you go, how to compare a sample mean from a population mean, and how to organize them in a statistical table. Remember the general idea. When any distribution statistic is greater than its critical value, we always remark it as significant difference. In a quantitative research or data analysis, it is important to arrange everything in a clean statistical table that makes our data easy to understand. What we presented so far are basic concepts comparing the mean of two groups. We may have omitted some columns in the table, but we will discuss them in future videos. But this is the main essence when we compare groups in statistical analysis. If you remember this idea by heart, you will be able to understand even the more complex data analysis and complicated statistical tables in the future once we enter quantitative data analysis. For your practice exercise, here is a sample task to work on. Alright, this concludes our video for today. Hope you learned something new and have a friendly day!